Hi everyone. Thank you for coming to our Frost server community call. I think probably most of you know what Frost is, but I'm just going to give a quick overview to remind you. And I'm Natalie. I work at the foundation. I'm one of the engineers on Frost. So what is Frost? It stands for Flexible Round Optimized Schnorr Threshold. It's a signature scheme that was designed by Chelsea Comlow and Ian Goldberg. So it's similar to multi-signatures, except that it's got a threshold. So the key is split into n shares, but the signature can be generated by a subset T of the participants. So it means that if you've got 8 participants, then you can say, okay, but I only want to make sure that at least 3 of them can, the approval of 3 of them to actually sign something. And so you can do this, you can generate a signature without having to recreate the full key. We have 2 methods of key generation. There's trusted dealer, which, as it sounds, is an independent dealer who generates the key shares and shares them out. But they can also be a participant, but they don't have to be. The other option is a distributed key generation method. So this is where the participants, well, you don't need a dealer, so the participants generate the shares amongst themselves. And the advantage of this as well is that the full key is never instantiated, which is obviously great for security purposes. So we have a few roles, which we'll be talking about. So the coordinator is the person who chooses what message is to be signed, and they'll choose which of the participants will be involved in generating the signature. So they will choose at least T numbers of participants. And a participant is someone who has a key share. The signer, when we talk about a signer, we just mean those participants that are involved in the signing of a particular message. And the trusted dealer, as I mentioned before, if you have one, they handle key generation. At the foundation, we have created Frost Core and Cipher Suite crates. We've got 6 Cipher Suites, and they handle all the cryptography. But the communication between the participants, that's up to the caller. So they need to decide how to handle it, how to handle communication, how to authenticate, and how to manage the keys for encrypting and authenticating. So enter Frosty and Frost Client, and Conrado will talk to you about that.
Hello, I'm Conrado, cryptography engineer at the foundation. FrostD and Frost Client, they have 2 purposes. The first one is to act as a tool to do real-world usage of Frost. You can sign Frost today using these tools. But they also work as a library or an example for other applications to integrate Frost with the applications like wallets, for example. So we start talking about the server, which is called FrostD or Frost server. This is a server that helps participants communicate with each other because many people are behind firewalls or NATs, and that makes it hard to open direct connections between them. So the server helps relays messages between them. It's a HTTPS JSON server. It's very simple. API-wise. And the server itself doesn't really care about the content of the message. It's not even aware it's related to Frost. But of course, clients need to end-to-end encrypt message. Otherwise, the server could read the content of the message. But of course, our clients do that. And the way this server authenticate clients is basically inspired on the fact that Frost itself requires some form of authentication between participants because each participant need to know who is sending message to them, and also in some applications also need to encrypt the message, for example, Zcash for privacy reasons. A key assumption of Frost is that everyone needs some key a key pair to authenticate peers. So the idea is that since everyone already has a key pair, why not use this key to authenticate to the server? So the way this works, the coordinator will create a session authenticated with their key. specifying the public keys of the other participants. So the other participants do the same, they authenticate using the key, and then the server know who can talk to who else. And the good thing about this is that makes the server stateless. We don't have like, we don't need a user password database, nothing like that. Though at some point we might add some state to pursue signing sessions, because currently if the server restarted, for example, participants will need to recreate the signing sessions from scratch. And the other side of, we have Frost server, but also have Frost client. And Frost client is a command line tool that allows you to use Frost by talking to the server. This tool has multiple subcommands. The main ones are listed here. DKG, which allow you to generate a Frost key shares using distributed key generation by also talking to the server. You have Trusted Dealer, which mainly use it for tests, allows you to create a bunch of shares locally. The Coordinator tool allows you to start a Frost signing session, and Participant tool is the matching tool that allows you to participate on a Frost signing session. And there's a bunch of other subcommands to manage contacts, export, import, and also manage groups, which each Frost share group is in the group in this tool. So you can list them, remove them, and etc. And all of this information, the contacts, the shares, are stored on TOML file, including secret shares. So please be careful. Don't, if you try this tool out, don't ever share your config file. There's a separate tool that we are using, which is called Zcash sign. This is basically what bridges Frost with Zcash. So this is a helper tool, because everything that I showed doesn't care about Zcash, right? It could be used for anything, but this particular tool is a bridge with Zcash. So this allows you creating a unified full viewing key and an address from a Frost group key. And this tool currently supports assigning a Y-wallet generated transaction plan by inputting external generated signature, in this case, the one that we generate with Frost. This is because Y-wallet is currently one of the wallets that support like offline signing. So we basically use this to help integrate with Frost. So it generates a transaction plan that you sign externally, and then they import the signed transaction, broadcast it. But we also will eventually update this tool to support PCZTs. So PCZTs is a partial created Zcash transaction. This has been added by the ECC devs to support the Keystone wallet, but it should also help integrate with Frost. So this is an overview of the full architecture. I think it's easier if you see them. So the first step that we're going to show you, we're using Y-wallet we use the Frost client to talking with FrostD and other Frost client participants to generate a wallet that we will import to Y-wallet. But then we're going to generate a transaction plan that Zcash sign will read. And then by using Frost client, which talks to FrostD, we will generate a signature that we will input in this tool, and it will generate a signed transaction that we finally broadcast with Y-wallet and will hit blockchain. So yeah, demo time. We have to do this a bit differently because John was going to participate, but he has some technical issues, but we can do with 2 persons. That's the beauty of Frost. You can do with 2, with 3, with 4. Just a single person doesn't make sense. So the first step, let's say we want to create a new Frost group and then create a Zcash wallet from it. The first step is that you need to initialize your config file, but we have already did that. So we just need to run this, but I'm not going to because I have already run it. But I'm going to export my contacts. So this basically, this is the name that you're using. You can choose a different name if you want to use different like aliases. And the public key that you're sharing with the other person. This is encoded to a string that I need to share with the persons that I am creating a wallet with. So I'm posting here in the webinar chat. I don't think everyone will see that, but that doesn't matter. And Natalie can do the same thing, export her contacts and paste into the chat, and then we'll import each other's. I'll post for everyone to see, just to see how it looks. There we go. So this basically encodes a string that encodes their name in our public key. And then I just need to import Natalie's contact that she just posted on the chat. And there you go. I have her contact. And if I do Frost client contacts, you can see Natalie's key and John's key that I had previously imported. So now we're good. We have each other's contacts. So this allows you to open end-to-end encrypted channels. So what I'm going to do, I'm going to run the KG, start a DKG run. So I'll be creating this ZF demo group 2 using this server, which is a server that we have right now for development. And I need the 2 participants' public keys, right? So I'm going to use Natalie's, but also I need my own, because I also want to be part of it. I'll keep threshold 2 since it's a 2 of 2 group, and this is Red Palace Cipher Suite that we need for Zcash. So I'm running this, you log it to the server, and is waiting for other participants to start. So I'm waiting for Natalie to run the matching command, which is basically the same, but without having to specify the signers, because I have already did that. There you go, it's happening. So there's a run round, you need the broadcasts round to make sure everyone got the same thing. And it's not maybe not work for Chochu. We tested with 3 participants. So of course the demo demons are affecting us. You look the same, right, Natalie? Just waiting for. Yeah.
Yep.
Yeah. Sorry about that. I think there's probably a bug when you use 2 participants. We didn't test that particular scenario. I can do, I could fake 2 participants. But yeah, I'll not improvise, right? What would happen if it worked? Sorry about that. I basically would add a new group in the config file. But sorry, let me just answer a question from Paco. Could Frost client have a mode where we return JSON responses? Maybe, yes. Like it's very simple to interface with the server, but yeah, you need additional logic, which is inside Frost client. But yeah, we could make return JSON, but it's just the logic's tricky, right? You need to manage a contact, basically a config file with the contacts in the groups, and that's a lot of stuff. So I think the best approach there would be to use Frost client as a library, right? If you want to use it, you could import it as a library. We might need to do some adjustments related to that, but I think the goal is to use Frost client as a library, not like not your program to call Frost client directly. Cool. No, I think the rest will work, right? I just need to skip the group creation, but we had already created a group before, which you can see here. We had created this group, I'll just show you how you would import into iWallet. So let's pretend everything worked out. We have this group here. Here is the public key and the public key of the participants, Natalie, me, and John. So I'm going to generate a unified full viewing key from this group public key, this one. I'll explain this flag later. But basically, this generated me an Orchard address, Orchard only unified address, and a unified full viewing key, right? So if I copy this full viewing key and I go to iWallet, you can go to accounts. You can see that I have many tests before, but basically you need to give it a name, click restore an account, and paste the unified full viewing key here, right? And if you do that, I think it won't work because I already imported this particular key. Let me just, no, it worked because yeah, some technical details that I won't go into now, but yeah, we have this wallet here. I will open the previous one we had created because it already has some funds in it. But yeah, that's the step you need to do to import the wallet into a wallet. And at this point, you could send transactions to the wallet, right? You can share the address, right? One important caveat is that due to technical limitations in my wallet, it doesn't support like an Orchard only wallet. So we need to create a dummy sapling component. And if you send a transaction to the sapling address, you will lose, sorry about that. Yeah, if you send to the sapling component, you will lose your funds, right? So make sure if you use this tool to only use the Orchard address or this address that is printed here to receive funds, right? When we migrate to PCSTs, this won't be a problem anymore. But yeah, be aware if you're trying this at home. So yeah, let's pretend you have sent some funds to this wallet by using the Orchard address. And now we want to generate a Zcash transaction, right? Cool. So the first step here is to create a transaction plan here. So we just pretend like if you see at this address at the accounts table, you can see this is snowflake. It's just a funny coincidence that is the same logo used for Frost, but this is because it's a cold wallet in my wallet, right? So it doesn't have, we don't have the signing key here. It's just a viewing wallet. So let's send some funds. I'll just pick, Zach Fawcett's address here to make a small donation. I have 001. I will just send 000 0001 just for, this is just a test. I'll just press here. Frost. If I click send, it will show me the transaction plan, and if I click here, it will show me QR code, but I'm more interested in saving this to a file. So I'll save this to this file txplan.json. I'm going to replace the old one. So I have a transaction plan in my hard drive, and this is the thing that I want now to sign. So let's go, I use the Zcash sign tool. So sign, use the transaction plan, use this particular unified full viewing key that I'm going to paste here and save it to this tx signed raw file. So why it didn't work? All right, I copied the wrong, just a second. I need to use the older full viewing key. I probably can get it from my wallet. Just a second. Yeah. There you go. No. sorry, I just need to figure out where I say. No one say I saved this. Yes, I have. Did I forgot to back it up? Sorry, everyone. Demos are like this. This is the group. Unified Fury key. I will probably have it on my bash history. Maybe it's this one. Yeah. This one. Sorry about that. I'm thinking. Yes, if was good. I did generate the right account. Let's code this one. Let me try that again. Do you have any ideas, Natalie?
Yeah, I just did you use the right, because we've got two different groups in there.
Yeah. Yeah. Yeah, but I still just like I haven't really interfaced with the groups, right? I just didn't write to unified filling key that generated from the account that generated this transaction plan, which is the one that we did last week, but I think I might have forgotten to back it up. And I think it doesn't work with what Y Wallet has for some reason. It should work. Let me try it again. Transaction plan is the one that I just created. Unified filling key. Oh, I think that's it. Yeah, worked. I was using the wrong clipboard. Cool. That worked, right? So what happened now is that the Zcash signing tool read the transaction plan generated from my wallet and the unified viewing key that we generated earlier, or that you can export from my wallet. And now it produces a Zcash and a randomizer. And these are the things that we need to sign with Frost, right? And is waiting for us to input a signature here. So I'm going to open another terminal and I'll do, let's do the Frost sign, right? So I'll just run Frost client groups to review the group that we have. We have a single one here. And I'll start a coordinator that will start the signing session. I just need to replace the group public key with the one that I want and the two participant public keys. So that's me uh, and Natalie. So the message will be read from standard input and the randomizer the same. So around that, and it's prompting me to input the message to be signed, and I want to sign the SIG hash, right, produced by the signing tool. And also needs a randomizer. The randomizer is a Zcash specific thing. It's basically what allows you to randomize your public key, so it's not obvious that when you produce two different transactions, it's not obvious that you have the same public key. But it's just technical details. So the coordinator logged to the server, and now it's waiting for the participants. So I'll be one of the participants, and Natalie is going to be the second. So now we just need to run this second command here, called participant, and I just need to specify the group public key, which is this one, right? It works because there's only a single session with us, but if you have multiple sessions open, we'll need to use the Frost client sessions command to yeah, this is exactly what happened, because the DKG session we had earlier is still running. So I just need to list the sessions we have. Yeah, there you go. There's 2 sessions. I'm not sure. Well, could use any one of them because no, one of them has the. No, let me do something. Have you already run your command, Natalie? No, no.
I also had
Cool.
multiple
Yeah.
sessions.
Just wait a second. There's a session handling is something that we need to improve a little bit. But this should close out the existing sessions. I'm glad I added this comment. Right, if I run this again, yeah, no active session, so I can restart over. Right, so let me go back to the coordinator, message to sign, randomizer, waiting for participants, so let's start the participant. Yeah, logging in, join sign sessions, send commitments, and then Natalie can run the same command. Right, so we both have sent commitments to the coordinator. The coordinator generates a signing package that is sent to the participants. So now the participants receive the SIG hash, and they need to decide if they want to sign it or not. This is one specific and very important thing that is missing from this tool. So for Zcash, we want, instead of showing a hash, right, the user has no idea what this means, we need to show the transaction plan, right? They need to agree, oh, I'm sending this amount of ZAC to this address, right? We haven't implemented this yet because it just will be much easier to do with PCZT, so we're waiting for when we add PCZT format. So yeah, just be aware that in your application, you need to show the participant the transaction plan, not just the hash, right? But yeah, it's asking me, do you want to sign this? So let's assume I'm aware of what's about and I want to sign it. And it sends the signature shared back to the coordinator. Natalie should have done the same, and there we go. The coordinator produces the signature, and we can copy the signature and paste into the signing tool, which, oh, it got 2. Yeah, we need to do that again, Natalie, because this is something that happens because when a Zcash transaction has 2 inputs, we need to do 2 signatures, generate 2 signatures. So yeah, yeah, this is the demo that everything was expected to happen, but let's see if we make it work. You just need to run the participant again, Natalie, with the same parameters. There we go. Another SIG hash to sign. Another signature produced. Another signature pasted. And we got an error. Yeah. Yeah, I might, let me think. I can try to force In my wallet, you can force to use a single note. So maybe I can try to quickly generate a new transaction. Transaction plan. Run the signing tool again. A new Zcash, a new randomizer, coordinator, Zcash, randomizer, run participant again. Natalie, if you can run participant again, please. Do you want to sign it? Yes. The coordinator is waiting. Generate a signature. Input the signature. And yes, we got the signed transaction here. Yeah, we need to sort it out, sort out the bugs, but we managed to make it work. We have a signed transaction here, which we can now go back to my wallet and choose broadcast. And this can read a QR code, but I just picked one from a file, tx which it has just been broadcasted into the Zcash network. And there you go. Zcash signed, Frost signed transaction, waiting for the minute. So that's it for the demo. Sorry about the hiccups. We're going to sort them out. I think the only one, yeah, we have to look why we can do 2 of 2, and we have to look into why 2 inputs is not working. But cool. Let's resume the presentation. So this was the demo, right? We showed how to sign a Zcash transaction using Frost, using Frost client and Frost server. Like I'm in 2 different parts of the world. We managed to generate, to sign together as a cash transaction. So what I want to do now is give an overview of the server, right? I think it might be interesting. Probably if you're a developer, but if you're also just interested in Frost, it might be interesting to understand a little bit how the server works. The usage flow is explained here, but I'll explain as I go over each endpoint, right? So this is a HTTP JSON server, right? So the input is a JSON and the output is a JSON. So to sign into the server, you need to generate a challenge where the server just sends you a random UID. And to log in, you need to sign this challenge using your authentication key, the one that we shared between ourselves at the beginning of the demo. So yeah, the tool needs to sign whoever is interfacing with the server needs to sign this challenge and call login, passing the challenge, the public key that you're using to sign, and the signature. And the server will return an access token, which is basically like a cookie that proves that you logged in for this particular public key. If you can log out, but you can create a new session where we specify the public keys that will interact with the session, right? So if you're a coordinator, we will pass the public keys of the participants. And this message count allows you to, the service allows you to like sign multiple messages. And this is basically just repassed it to the other participants. And this outputs a session ID. And this session ID is the one that identifies a particular signing session. This is what this sessions returns, right? Every session that you're participating in. And you can also return information from a particular session where it lists the public keys and the coordinator public key. So now we have send, which allows you to send a message to someone, right? So send this message to this recipient in this session. Again, the server doesn't really care where you send, but you should encrypt end-to-end encrypt message. And receive, right? It's the opposite. You basically tell the server, "Oh, give me the message for the session." Since you are already authenticated, it knows who is asking for this, right? But in some case, like if you're both coordinator and participant, you need to disambiguate between if we're asking this as a participant or as a coordinator. So this is what this flag is about. It will turn a list of message that has been sent to you, the sender and the message, right? And of course, when you receive this, you should authenticate to see if it's truly the message has been truly sent by whoever is claiming to be the sender. You can close the session, and that's it. That's the whole API of the server. It's pretty simple. But of course, you can interface with it by just using any JSON RPC library to do this. But you might also want to use our tool like as a library to interface. Like we probably need some API adjustments to make it work as a library, but we more than willing to help do that. So if you start work on this, let us know so we can coordinate. So yeah, I'll briefly talk about what's next. Let me go full screen. So yeah, we need some improvements to Fast Client, specificity support, like I mentioned. We need to add the ability to sign multiple messages at the same time. Like we have showed you, sometimes you need to sign two things at the same time for a single transaction. And it will be helpful to do that without doing the whole process twice. Then, and also the things I mentioned, the prompt to see if we need to show that it's like in the slide. We need to show the transaction plan before you decide to sign it or not. And of course, fix the bugs we have just found. And also something that's going on, I think is important, is that all this code is being audited by this authority. They have already produced an initial report with some findings, nothing major, but some stuff that we need to fix. We are already fixing, nothing super complicated to fix, but so this should be done soon. And with that done, we believe this project we kind of wrap it up, right? Because the next step will be integrating with this. In our opinion, the next step will be to integrate this with wallets. But we, the Zcash Foundation, can't work on this right now because we need to concentrate efforts on Zcash deduplication. But if there are any wallets interested in doing this, we need to help. We know that Zingo is interested in this, but they are also very busy with design work towards the cache deduplication. But yeah, talk with us if you want to do this. And I saw that James Katz is thinking of doing a proof of concept of GUI version of this tool, which also will be very cool, right? Because not everyone can use a command line, and a GUI version will be really cool. And I think that's it. If you have any questions, please ask them now in the chat. But I invite you to check out ZCon Virtual, which is happening in a few weeks. We're going to have a presentation about what we're doing at ZF, about Zebra, and about Frost. We probably will do the demo there. Hopefully, we'll work out all the bugs at the time. And also, there's many other interesting presentations there about Zcash in general. And that's it. If you don't have any questions, I'll wait a little bit for any questions to come up, but that's it. Thank you for attending, and sorry about the about the issues, but we did manage to get it signed. Oh, cool. James just mentioned in the chat that he's releasing a video of the Trusted Dealer working. Cool. Yeah, Zero Darts mentioned UX, and that's a really important thing. I think the biggest challenge with Frost is UX, right? you can see that's kind of, I mean, we try to make a tool that's the most straightforward possible, but there are kinks related to like how to handle multiple sessions, how to store the participants' context, right? Because you need the participants' context even before generating a wallet, right? So many people suggest, oh, I can use a blockchain to send message, but like you need something before even creating the wallet, right? So it has some tricky challenge. So yeah, I think the UX is the biggest challenge here. Can Frost client recover key shares? Not yet. We haven't added that functionality or create support recovering shares, but Frost client not yet. It shouldn't be really hard to add support because the workflow is very similar to the Kiji. So yeah, we're probably going to do that at some point, but no concrete work right now. Also, there's recovery key shares, and there's. Can you remind me? Natalie always mix the recover, repair. Yeah,
Repair, share, and refresh.
refresh. Yes, repair allows you if you lose your share. Repair shares allows you to recover it from if you have a threshold of other participants. They can help you recover a share. Refresh your shares basically allows you everyone to like create a new share while maintaining the same group wiki or the same wallet, right? But everyone's refreshes their shares. This is important to do from time to time to mitigate against attacks. Does Frost client and FrostD repos have good first issues for people interested in contributing? That's a great question. I think there's a lot of stuff like that, like adding support for multiple messages. Yeah, I need to write these things out. I'll try to create a bunch of issues with a good first issue label. But yeah, definitely there's a lot of low-hanging fruits that we have got around doing because they weren't a priority. But I think it's a very like I won't say simple, but a straightforward project to start contributing to, like much simpler than Zebra, for example. So if you're interested in it, feel free to drop by. We have the R&D Discord. There's a Frost channel there. So but also feel free to reach out to whatever channels you're in, and we're willing to help. Yes. Cool. Thank you, Paco. Any other questions? I saw there's a QA tab. Yeah, but they have been already been answered. Yeah, I think we can wrap it up then. Thanks everyone. Thank you, Natalie, also, and Elise for setting this up.
Thank you, everyone.
See ya.